All right.
All
We
right.
should be live.
Should be live. Alrighty.
Should be
Yes,
here.
sir.
What's up, Jose? How you doing?
I'm doing good, brother. I'm doing good. Uh, I'm doing good. Ready for another stream. Another some league code. Right. A little bit tired, a little bit sleepy, right today. But hey, I'm here to grind. I'm here to finish some coding problems, and also I'm a little bit excited and worried. Excited because the semester's about to finish. But and I'm a little bit worried because even though the semester's about to finish, there's a
Mm-hmm.
lot of things going on, right? A lot of assignments, it's tests. But overall, I'm excited. I'm happy to be here another stream. But what about you, Carlos? How you doing?
Doing all right, man.
Yeah, yes,
Yeah.
sir. Good to hear, my guy. Any basketball? Any any stories? Basketball stories or anything?
No basketball. Um, I guess the only other story would be the race that you
Oh
left.
yeah, 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 yeah. Uh huh. Yeah.
Um, did a race with one of our buddies. He was talking smack, and I had to show him who's the fastest in the group.
Was it the fastest in the group? Yes,
Yeah.
sir.
I mean, not to bring Jose into this, but like I beat Jose first, you know,
Oh my God, bro. Nah, 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 nah.
and
Yeah, he did. He did. He did.
and I told this other person in the group that, hey, I'm the crown right now. I'm the crown. I'm the king. And he wanted to challenge me, and he immediately started chirping at me. I could wear bricks and still beat you, or stuff like that. So I didn't take that lightly.
Damn,
I
bro.
wanted I wanted a good competition match. I came prepared, had my shoes stretched. I didn't took off my pants with shorts underneath. I had shorts underneath.
Hey, yo,
Took off my
pause,
pants.
rewind, pause, rewind, my
I
guy.
had
Nah,
shorts
I'm kidding.
underneath, and we did a good run. We're not gonna leak the footage, but we have some footage as well.
Bro, I'm just
Uh,
saying, bro. Carlos was running, bro. Like he had some, I don't know, bro. He had some motivation. He was like, boom,
yeah,
boom, 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 right?
there was two
Damn, bro.
attempts. We the first one I didn't. I pushed off of one leg to start because you know how like you have like that
Yeah.
position. I pushed off my front leg, and that was the worst
Mhm.
decision ever because I barely got any speed off the jump, and we
Yeah.
tied. So if I messed up like that and we tied, the second attempt where I pushed off my back foot and my front foot, oh bro, it's over.
Damn, bro.
I got the best start. I was gone, dusted.
Eh, but either way, we still, we need to do a rematch though, because our friend over here, he was like wearing some Converse, his sweater,
What
he
happened?
wasn't
But
fully prepared. He wasn't fully
what happened
prepared.
to I could wear
He wa-
bricks and
he
beat you?
wasn't fully prepared.
What
So
happened
we
to
have to do
that?
a rematch.
No,
We
no,
have to
no. I
do a
don't want to hear
rematch. No,
that.
no,
I
no,
will do
no.
a rematch. I will do a
Even
rematch, but
playing field,
I don't want to hear that
even
because
playing field.
they were
You
talking
know,
smack that they could wear bricks and they could beat me. So now
nah, nah,
it's,
nah,
oh, I
nah,
wasn't prepared, or yeah,
nah,
right,
nah,
man.
nah.
I'll do a rematch.
No, even
I'll still beat him.
even
That's the funny
even
part.
playing field, but running shoes, shorts, and then if you beat him, I'll be like, fair, you're the king, you're crowned as the king of the,
That sounds like their problem. They're
But right
talking all that
now,
smack and they
I
didn't come
don't know.
prepared. That's crazy. Imagine that.
I don't know.
Do you
I don't
think
know.
they
I don't
think
know.
they could win with whatever they had on? So that sounds like their problem.
I
For
don't know. And
me,
also,
I said I'm not wearing no pants. I'm not wearing my crappy shoes because I'm not trying to get hurt. You
nah,
think I'm trying to get hurt over
yeah.
here? No.
Mm,
So hey,
I
you know what?
know.
Matter of fact, since you're talking, I want to put you on the line too. Well, I'll race and I'll beat you
Nah,
too.
I'll lose. I'll lose. I
I'll
admit
I'll
defeat.
turn
I
around
admit
and look at
defeat.
you, man.
I admit defeat. Yeah, yeah, yeah.
But to give Jose
But
props, he will dust me in distance. There's no question
a little
about that.
bit, a little bit, a little
He
bit.
could go as long as he wants. I'm gonna be finished. I'm gonna be in my room, showered, everything, sleeping. Jose's still running. So, um, so Jose knows that maybe speed, like
Speed is not
immediate
my.
speed, isn't his strong suit.
Yeah.
Either mine, neither is me. I'm just happen to be the fastest in the group though.
Uh-huh.
Is the thing. But Jose, man, he's like a gazelle. He could run forever.
Nah.
So,
A little bit, here and there, here and there. You know.
anyways,
But damn.
that's it.
With that said, you know, we'll have a rematch. Just in case, even playing fields and stuff. But for right now, Carlos has won for sure. He's the undisputed 2 for 2. Uh, that's his record right now.
Two
So,
for two.
I'm ready to start whenever you are, brother.
I'm here. I'm
I'm
ready. Let's
excited.
switch the screen.
Uh, we just already okay, fair enough. Um, Also, I was gonna say we are gonna deviate a little bit. I know we were talking about this before the stream. We're gonna deviate a little bit because we saw that trees are gonna be they're hard problems, so we're gonna spend quite the amount of them, and they're hard, so they're meant for that. Meant for you to think about the different solutions and stuff. But for right now, since we feel comfortable with trees, but not as comfortable, we're gonna deviate a little bit, and we're gonna work on some other problems. I think is dynamic programming, so you guys can get some. So you guys, for the stream wise, get some problems finished, right? And not just be stuck in one problem, right? For like 2 or 3 streams. So we're gonna deviate to dynamic programming. Hopefully, this is gonna give us some problems to solve. And we chose dynamic programming because right now, in one of our classes, we are studying dynamic programming. So it's just gonna be like a refresher. It's gonna help us like fundamentally learn what we're learning in class. So it's just gonna be it's a win-win situation for us and for you guys. So with that said, I think we're gonna do climbing stairs first.
Climbing stairs, man.
Yep, yep,
Exactly what
yep.
Jose said. We didn't want to stay on a problem for multiple streams. Um, I feel like that would do disjustice to the viewers that watch. So we wanted to switch it up. Dynamic programming. You ready?
Yeah, yeah, yeah.
You
I'm
want me to
just
read
doing
it?
the little timestamps right here.
Okay.
You tell me, brother.
I could read it for you.
Okay, bet, bet, bet.
So number 70, climbing stairs. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top?
Okay.
For example, you got an input of n equals 2. The output is 2. The reason why is because there are 2 ways to climb to the top. You take 2 1 steps or you take 1 2 step.
Yeah.
Output 3. I mean, for example, 2. You get an input of 3. Output is 3. Explanation: there are 3 ways to climb to the top. You could take 3 1 steps, 1 2 step, and 1 3 step. I mean, jeez, Louise, man.
Come on,
One
brother.
one
Come on.
step and 1 2 step, or 1 2 step plus 1 step. Hmm.
Mm-hmm.
Hmm.
Okay.
So you gotta find out how many different options do you have.
Yeah.
Rather, you don't need to find the most optimal one.
Yeah. Yeah, by doing one or two steps. 1 step, 2 steps, 1 step, 2 steps.
Okay.
Yeah. You either take 1 step or 2 steps. Right. Every time you take 1 or 2.
Yeah.
Yeah. I think this is an Excel draw problem. Let me pull
Next
it up
Skelly
right
draw. All
here.
right, let's get a Skelly
Yeah,
draw out.
cause
And what's
for
up with
what?
this right here? What's going on? Oh, test cases. Oh, okay, I see.
Yeah,
There you go.
bro. He was ready to bash on it, bro. What the
My
heck,
bad, my bad,
dude?
my bad, my
Yeah,
bad.
bro. He's looking for that bug.
I'm a bug hunter.
He's a bug hunter, bro. Gotta get he's a bug bounty.
Yeah, bug bounty. All right, let's
Okay, here,
get
I got you,
this.
brother. Yeah. Tell me if you can see it.
Um, yeah.
Yeah, let me just. There, yeah. I'm in the little page. Yeah,
Okay,
yeah, I'm
I'm
right
here.
there,
I'm
right
here. I'm
there.
here.
Let me just turn this into. There you go. Yeah, I can see it now. All right. So let's see. Let me. Let me see. Let me see. Give me 1 second. Let me get the picture of the problem right here. Uh-huh. Bro, I have so many tabs open. I have to close some of them. I got you. Okay, I'm here. I have it right there. Uh-huh.
All right.
Okay, ahí está. There we go. Okay, so let's think about it. Let's think about it. Let's apply what our professor told us to do.
Okay.
So one thing that I've learned, right? One of my friends told me a couple weeks back is that recursion, you have to assume it works, right? Like you have your solution and you have to assume it works for other solutions. I don't know if that makes sense.
Sure.
Yeah? Yeah or nay?
Sure. I'll
Sure?
keep going with it. Keep going with it.
Okay, so for here, first, I think we need a base case. A base case would be if it's over. If the steps, right, or base case, right? I'm gonna do it to the right, to the left. No, to the yeah, to the left, to the left, to the left, right there. So I feel like the base case, right,
You
is
and
going
your.
to.
Sorry, I guess I'm just hating today.
Oh, well,
I'm
fair, fair.
sorry.
You know,
I'm just
it's
hating.
all right. No,
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 I'm
just
hating. I'm hating.
no, no, no. I got you, brother. I got you.
I'm
Right
hating.
here.
I'm
There you
hating.
go. I'm gonna do it extra large, brother. There we go. And wait, wait, give me a sec, give me a sec. Right there, brother. Right
Okay. Okay, we're good now. We're back. We're back.
there. So my base case,
Uh huh.
I think, would be when the sum, right? And the sum is the amount, the how many steps were, or how many steps
The
we have,
end.
pretty much. Yeah, the n is greater than n. That's our base case, right? Because we either had take one or two, right? So if we hit two, right, we found if we one or if the plus one, if sum plus one equals n, we're good, right? This is good. This is positive. Sum plus two equal n, this is also positive. But if the sum plus two is greater than n, right, this is a negative, right? Yeah or nay?
Uh,
Or also,
I'm not understanding this. The sum is what again?
the sum is the amount of steps we take it. For example, step one, we do one step, right? So sum is going to equal one. Another, it'd be like we take two steps, so sum is equal to two. So the sum is just the amount of steps we have taken up to that point.
But what do you mean equals n?
Equals n, n is a number of n, because right here we're trying to look for n. Because it takes n steps to reach the top, right? So we're looking how many steps, one or two steps, can we reach for the top. Yeah.
Yes.
So the amount of steps we take has to equal to n, right? Because n is giving us, all right, to climb up this building, we have and we have to climb up this building, you have 100 steps. So you for sure need to take 100 steps, right,
Yeah.
to climb up to the top. So you have the option to either take one step or two steps. So you take one step and then right now sum equals one because you're taking the sum of the amount of steps you've taken, right? So the sum right here, it's sum uh sum equals to the number of steps taken up to now. Oh, what the heck happened here? Right here, like that. So the number of steps we've taken up to now, right? So if the now with the current steps of 1, right, and if we do add the plus 1 and it's equal to n, that it means that we've reached the top with that plus 1. If sum plus 2 equals to n, that means that we've reached the top. Yay or nay?
Yes.
Yes?
Yes.
Yeah? Now, but if we do plus 2 or plus 1 that equal greater than n, that means we've like overstepped n.
Overstepped.
Yeah, overstepped. And I don't think we're gonna be able to understep, right? Be like, oh, we reached step 99, right? We can't go up anymore. Well, you can because you can still take one step,
Yeah.
right? To get to 100. So our base case is when sum plus 2 is greater than n. Or, right, if sum plus 2, or when the sum it's equal to n. These are our base cases. Yay or nay?
Yes.
Yes?
It's gonna
Okay, this
stop
is, it's gonna stop if we go over,
if
or it's
if
gonna
those
stop
two
when
are
we
hit.
hit. Yeah, yeah.
Okay. Yep.
Those are my base. That's what I think. I'm not sure, but that's what I'm thinking. I don't know how.
Okay.
What about you? What's your insight? What's your input?
Um, I think you hit it right. Uh, because you're right. You're
Uh
not gonna go less because
yeah,
you could just add one.
yeah,
Or if you're like less by two, you add two. You know.
yeah,
So
yeah,
it's either you're gonna overshoot it or you're gonna equal it.
yeah. Pretty much, yes. Yeah or nay?
What about if will they ever give us if n equals 0?
Well, if n equals 0, sum is 0 at the beginning.
Okay.
So 0 equals 0 is just gonna like, hey, we know it's gonna bounce back.
Okay.
Yeah. Yay or nay?
Yay.
Yeah. All right. Fair, fair, fair. Okay. Okay. Yeah, that's the way I understood it. I might be wrong, but let's explore this idea. So we got these two base cases, right? So let's say we're given n. Let's say we have 5. N equals 5.
Okay.
Yeah. We got two possibilities.
Wow,
We
you did
got
that really
one.
nice.
Hey, thank you, brother. Thank you, thank you. Try my best. I tried my best, bro. It's one of the things that I'm trying to like master the little squiggly line, because
Yeah.
you know how some professors go like this and they go like that or something like that.
Yeah.
I have to do a two-parter where I go start at the top and start at the bottom.
Wow.
Hey, thank you, brother. Thank you, thank you.
I usually sometimes I just like wiggle it in the middle and then call it a day.
Yeah,
Like I don't know if that makes sense, but all right.
I get you. I get you. All right, so we have to keep track of the number of steps we're given, right? Or how
Yeah.
many ways there are, right? So we're gonna have a counter here called.
I just
Okay,
forgot
so
something.
uh-huh.
I forgot to call my mom yesterday.
Ufas.
Dang it, bro.
Move fast, bro. The
Okay, I'm
chocolate's
good.
coming for you.
I know, man. Okay, I'm sorry.
All good, all good.
Keep
Oh, you can
track of
change
how
the
many
opacity.
steps.
Yeah, this yes. So we're given five, right? And this five, we could either take one step or two
Two
steps,
steps.
right?
Mm-hmm.
Wait, let me call this. I'm gonna call for f as a function. We can either take one step or we can either take two steps, right? So that's a function. That's our two options. We take it one or two steps, right?
Mm-hmm.
So if we're given five, what does it mean once? So five, the first iteration at this point, what does it mean? What are we trying to find out, right? Yes, we can call f and f5 minus 1, f5 minus 2, yes. But what are we going to keep track of? We're going to keep track of the number of uh okay, yes, we're going to keep track of the number of how
Options.
many options, yes, of how many times we are able to step, how many the different ways we can step to five, right?
Yeah.
So here we can have another variable called counter, right, which equals to 0, right? And this counter is just going to equal to counter plus that plus equal that, right? Plus equal that, and counter plus equal that, whatever f is. Let me just make it a little bit better. Oh, yeah or nay?
Kind of. I'm kind of understanding what you're putting.
Yeah, because here pretty much we go to 5 1, right? And then we get 4, and then we got the counter, right? I'm just gonna do CS counter plus plus, right? And we're gonna do f of 4 minus 1, f of 5 minus 2, right? So we're gonna 4. This is 4. 4 minus 1, that's 2, right? So it's gonna keep going all the way, all the way, all the way, all the way, all the way. And if this sum hits, right, we're gonna return a 1, right? A 1. We're gonna return a 1, right? But if it's over, we're gonna return a 0, right? So let's try it out with a smaller number and let's see, let's track it down, all right? So let's say 2, right?
Okay.
Or let's say 3. Let's say 3 since we have the
Three.
example of 3, right? So we got 3, 3, 3, boom, boom, right? So we, for example, the first call, this one, which is gonna go over here, we're gonna say, all right, 3, well, no, 2 now, 2, right? We got 2, then we got count, count, plus, plus, f of 2 minus 1, f of 3, 2 minus 2, right? So here, right, we already went to the base cases. We've seen that 2 does not equal 3, and 2, and the plus of 2 is not equal. Wait a minute. This thing is gonna affect us a little bit. Well, the sum, right? Wait, this is not the sum. Hmm. Oh, you know what this is? This is wrong. I've been thinking it the wrong way. Hear me out. Hear me out. Now I'm gonna move this a little bit up over here. That way you can see a little bit better. If you ever see me that I'm just like blabbing around and you're not really getting what I'm saying because I'm just talking nonsense, you tell me, my guy.
Okay.
Yeah. So sum, it's not the sum. It's just like steps, right? Or current steps, right?
Hmm.
That we're looking for. Current steps has to equal to 0 and plus 2. This has to equal to less than 0, right? Because here, if you notice, we're going down. We're going 3, 2, and then we're gonna do 1, right?
Yeah.
You're gonna do 1 here. So this one over here is gonna equal to 1. Boom, boom. C plus F 1 minus 1. C plus F 1 minus 2. Right here, this base case, this thing is gonna hit the first step where current equals 0. So there's
Huh.
a 1 in here, right? There's a 1 in there, right? Here it's gonna return a negative,
Yep.
right? It's gonna return a negative 2. So wait, give me a second. It's not gonna return here. It's gonna go here. It's gonna return 1 here. This is gonna return a 0, right? Because we were able to reach 2 or 3 doing 1 1 1, right? So we return, hey, this is one way, right? If we do all ones. But if we go negative, that means we overshot. It's 0. That's an invalid. So here we're gonna return 1. 1. We're gonna return 1 plus 0, which is 1, right? Because from up to there, there's only one option, right? So we're gonna return, hey, there's a one way here. Then we're gonna go to 2 here, this one, and then we're gonna say, hey, we're gonna say this one, we go over here, and then if we trace it down, it's gonna do 0. It's gonna bounce out to 0, right? This is another one, right? So this one is gonna bounce back and go all the way over here. We add these two, and then we go back here, and there's a 2 involved, right? So now this 2 goes all the way over here. Yeah or nay? Yeah or nay? Yeah or nay?
A nay.
Why? Why?
Because you're adding the results.
Yes, you're adding because you want the total number of ways you can get to that specific number. And the only way we can get to that number is when we subtract 2 or 1, right? And if you subtract 2 and 1 and if equals to 0, right? That means like, hey, there's no more steps to travel. We've reached the top, right? So if I go, for example, this 2 right here, if I go with 1 step, right, I'm just missing one more step and then do one more step, right? I go in here and say, okay, I got one more step to go. I either take 1 step or take 2 steps, right?
Yeah.
If I take 1 step, I reach the top. If I take 2 steps, I I overshot the top, right? So there's just one way to go, which is the one way. If I take 1
Okay.
step, so
So
that
then that
one
returns to
the
here.
sum. Yes, that returns. Well, no, that adds 1 and 0, right? Because if there's a 1, right? If this 1, right, the total number of ways to get to uh, n,
Yeah.
right? Having
Yes.
1 step to go is only one way. So
Yes.
1
So
plus
where does
0
this
equals
go?
1. This goes over here to this one over here. This one,
That's
right?
what I said.
Yes. Yeah. Yes.
So
And then
then,
this two, you go.
if this one is
This one goes
0,
in.
why
It's
is there a
0
1?
because we reached the top. Because here you have 2 steps missing. You need 2 more steps. You either take 1 step or you take 2 steps. If you take 1 step, you do this thing over here, right? Because you take 2 steps and then you took 1 step, you're still missing one more step, which is 1, right? That's why we travel all the way back here because you took
I'm
1
saying
step.
this one though.
well, this one, right? We have 2 steps, right? And you took 2 steps. So 2 minus 2 is 0, which means you reach the top by taking 2 steps.
What you mean by
You
this
go
right here?
here, 0 means like, hey, you reach the top. It's 0. It hits the base case and it goes back and you get 1.
So
And then
technically, it looked like, uh,
technically, it looked, there's no way to describe it because it's just a base case.
okay,
It goes into the base case, it hits 0, and it goes back up.
okay,
Here, you have to specify it because you have 1, and 1
yeah.
is not a base case, so you have to go through you have to go through this thing right here.
So this came over here.
Yeah.
This was granted because it's 0, so you hit the base case. So now you're at 1, 1.
Yeah, you have
Now
1,
you
1,
add
right?
these, it's 2. Okay,
That's
now
2.
where we're at.
Exactly. Right? So now we're at 3 minus
That's
2.
3,
And
2.
I
Okay.
think this should work. Not sure. So here, right? Hey, 3 minus 2, what is it? It's 1, right?
1.
So we already solved it over here, right? So to avoid drawing everything else and stuff, we can just use
Yeah.
this and say like, hey, we have 1.
Uh-huh.
1 plus 0 is 1. So this for sure is going to return 1. And then you just return 2
Ooh.
plus 1, which equals 3.
I like that.
Yeah.
I like that.
And this you can actually use, we can enhance it by using Memo,
Memoization. Memo.
Station,
Memo.
Memo, El Memito. That's what they call it in the Mexican streets. But
Oh,
yes, yes. It's because Memo is like you know how some people are called Guillermo?
nope.
No, like well, people his common Hispanic name is Guillermo, right? And like nickname of Guillermo is Memo. And then so if you see or if you know a person that's named Guillermo, you can call him Memo, right? And sometimes they call him Memito.
Okay.
Yeah, so that's why like a little trick in there. Yes. But
Thank you
yeah,
for
pretty
sharing.
much. Of
That's
course, I
something
got you,
new.
brother.
Something new. I like that. Okay, that
Yeah.
understands it now. Yeah, perfect.
Yeah, of course. Yes. So yeah, so we're just adding like the 2 ways, right? So we go
Mm-hmm.
one way, we say, hey, how many times we can count, and then even though without even tracing it, right? We can assume, right? Here we can just like return count, right? We can assume with this given right here, with all of this given, right? Ignoring the rest, we can kind of assume, hey, I got n3, and if I assume, I can assume that, hey, if I go count minus 1, I'm just gonna get the count plus 1, use the base cases, right? Uh, according to, in favor of myself, right? I'm assume that it works, right? Without even needing to do all of this, right? That's how I got the count plus equals and plus equals, because I kind of like assumed this F3, these things were gonna work. So you just keep track of the count and return count. I don't know if that makes sense.
Yeah.
Yeah. So that's pretty much how I saw it with the things. Yeah or nay?
Yay.
Yeah. Okay. You want to code it up and see how if it works?
All right.
Alrighty. Let's see.
So,
You can we can create a new function if you want. If you're down, we can implement some memoization, brother.
I think we should definitely do that.
All right, bet. Get some
Okay.
practice.
So, you want a new function.
Yeah, if you want to, of course.
What should we call it?
Let's just call it F.
F.
F as a function. Yeah.
And it's going to take
It's gonna take one parameter, which is the steps, the current steps.
steps.
Yeah.
Okay.
And then we're gonna do our base cases. We're gonna say if steps equal n or equal 0. Yes, equal 0. Equal 0. Yes, equal 0. We're gonna return a 1. Else, if steps is below 0,
Well, I
else,
think we should.
else if we can do. I think we can do an else if. Elif. It's in Python is elif. Yeah. Uh-huh. Return 0. Right. So that's our base cases. And now we're gonna do. Oh yes, we need a counter. We have to create a counter, which is we can set it to 0, right? And then here we're gonna say counter plus equals f steps minus 1. Then counter plus equals f steps minus 2 and return counter. Yeah, yeah, that works. Then let's call the function f, and I think you can do, yeah, return. There we go. Yeah.
There'd be an issue right here.
Let's think about it. Let's see.
Well, what would be better? If steps equals 0, return 1, and then another if statement after that says if steps equals or
Uh,
less than 0, return 0? Or
I don't.
because what
Let's see. Let's
happens
think about it.
if steps is greater than 0? Will it?
Well, if it's greater than 0, right, it's just gonna do the counter because there's still some steps to go,
So it
right?
won't
For example,
expect an. It won't expect an else.
no, because if it's steps equals 1, right, we still have one step to go, right? So we have to evaluate that one step, right? Um, but then the elif, right, it's gonna hit whenever steps not equal to 0, right? And that means where it's either positive or negative, right? So if it's a positive steps, right, positive, let's say equals 1, 1 is not less than 0, so it's not gonna return anything. It's gonna go straight to the counter and stuff. So
Okay.
I think it should work there.
All right. Run it.
All right, let's run it. Not sure if this is gonna work, but hey, yes sir. All right, let's check some test
Look,
cases.
I
Let's see.
hate.
Man, bro, bro, come on, bro. Man is tripping. He's trying to find the bug.
Let me see something.
Mm, right there. It says suggest for 4, 5, and 6. I mean, let's see. We run them through. Yeah.
So how do we incorporate memoization? Would that be including a data structure?
Yes, we have to create what's it called? Yes, we have to create a data structure. It depends on the variables that we're gonna use. For example, we either use a 2D array or an array. But for that, we have to think about it a little bit and see how to
Or a
implement it here.
dictionary?
We can do a dictionary, yeah. Oh,
But
let's
what would
see.
the name be? I remember something like I forgot who said it, but
Dictionary. I'm not sure how uh,
because if you have f of 1,
yeah,
then the value should be stored. Like if that makes
yeah,
sense.
yeah.
But
I
how
mean,
you would how you would create the key is what I'm confused
well,
about
with the
it.
key, we just have to. We just if we're just gonna do a dictionary,
Or you
we just
just
have
say
to.
1.
Yeah, key equals 1, and then if first we check if the key is there. If so, we just grab the value. If not, we just create the key and store the value, which
Yeah.
is the same thing as an array, where we just check if the value at that position is what's it called, uh, negatives or -1 or something. And then if it's not right, we calculate the value, right, and then we save it.
So you're
And
saying we
that's
populate an
yeah,
array n
yeah.
times to the n?
Not
Something?
yes. I was. Let's see. I Yes, with an that yeah,
With
that'd be
negative
fair.
1.
Yes, with n with -1. Yeah, yeah, yeah. Because we won't. I don't think we're gonna access. Since we're going down, all of our accesses are gonna be less than n. So yeah, n would be the variable
Would
to
that
detect the
be
size.
would that add more than a dictionary would?
I mean, space-wise, I think a dictionary would add a little bit more space because you have to store the key and the value, right? I'm thinking. I'm not sure if your Python really stores the key and the value, but the array just stores the value. But
But what
uh,
about you having to populate an array n times?
that is true. Yeah, we will have to. That's gonna take O of n. Yeah. Yeah. But I think also adding a value and a key to dictionary is O of n too. I'm not sure. Let's see.
You might be onto something. But you're not
Oh, it's O of 1. Okay.
adding all the f's in in the dictionary,
Well, same thing in the array.
but you're populating all of it beforehand.
No, that is true. That is true. Hmm. With a diction, I think a dictionary could work. Let's see. Uh, yeah, I feel like a dictionary could work. Yeah, yeah,
Dictionary?
yeah. But
Or
I
we
mean,
s
me personally, I would prefer to use an array since that's the way we're learning of
uh-huh.
it. But if you want to do a dictionary, we can do a dictionary,
How
or
about
we
we
can
do
do both.
both?
We can do both.
Let's do
But
both.
let's do it with array though, because
Okay.
I feel more comfortable with array. I feel like
All right.
that's let me see. But first, let's run the code and see if it actually works.
Oh. Okay, okay.
Yeah, and
Run
so
it.
we could also measure our
Time.
yeah, our time complexity. Let me just get the
Submitted.
timestamp. Oh, that's not good. Oh, that's not good. 38.
Wah, wah, wah.
Huh. Time limit exceeded. Huh. If it runs here,
I mean,
is there
we
is
have
there
to
a,
incorporate memorization.
is
There's
there
no
is there a constraint if you go down? No.
it's not a constraint. It's just that if we're going up, I think we should have if we the max is 45. Imagine 40 30, 45. You got to break it up and each one you got to break up the little one, each one break up the little one. There's no way. I think we needed to incorporate
Yeah,
memo
memoization.
from the
Yeah.
jump.
Let me see. Let me just confirm.
All right, confirm, confirm. Bro, my shoulder hurts, man. Oh. So memoization. I sound weird saying that.
Uh,
Can't believe. 38.
I mean, I think we have to, because it's not even. Try printing something.
What do you want me to? What do you want me to
Print
print?
print counter. Let's see. Just print something. Because it wasn't an infinite loop or anything. It was just time exceeded. Yeah, it's not running. Okay, fair. So yeah, I think we have to implement a memo. Hey, hello Ali, welcome to the stream. Welcome to the
Ali,
stream.
what's up? What's up?
Oh damn. Oh, did it run? Oh, it's because it's oh yeah. Okay, yeah, we have to implement a memoization. Yes. That's
Look
yeah,
at this.
bro.
Look at
Scroll
the
scroll all the way down. Scroll all the way down. Oh my god.
crazy.
Okay,
Okay. So
okay,
let's do your array thing.
yeah.
At the most we're
Oh
doing 45 population, so it's not that
yeah,
bad than I thought,
yeah,
I was thinking like millions and stuff, and I was like,
yeah. No, because that would be crazy, dude. That imagine take that. So we're gonna need
so
a let's call it memo. So we can be more fancy. So memo, I think you can go equal, yeah, times n.
can I do this?
Yeah, times n, times n. Yeah.
All right.
So let's think about it. Mm, yeah, we
If
just need a. It has to be on the top. It has to be on the top.
if steps
Before the if statements, I think. Before or after? No, yeah, right there, right there. So we have to check.
if steps minus 1,
Oh, you're onto something.
if memo steps minus 1 is not negative
Mm,
1,
I don't think we have to do -1. I think we just check steps. The -1 is are being dictated on the next one.
you're lagging a little
On of
bit.
them.
You're
Hello.
back. You're back.
All right, bet. I think we can just do steps. If memo at steps does not equal -1, return memo at steps. Uh-huh. And then over here on counter 923, 23 over here below right there. We're gonna do memo at steps will equal counter. No, I think we still need to return.
Oh,
What do you think? Do we return?
you're saying this.
No, we have to. No. We have to set memo at steps equal counter. Yeah, because we have to store it. And then right there, you enter a return counter. I think that should work. Not sure, but I think so. What do you think? What do you think? What do you think? What are your thoughts? What are your opinions?
This right here,
Yeah.
counter is
Counter's too big. It's the same thing. We're just doing the same thing, right? And nothing changes, right? But now we have to store the counter in the array, right?
So counter. Okay.
Yeah. Now we're storing counter in steps. For example, I go to one, right? And if it's one, I know for sure it's gonna equal to one. Ooh, fast. Ooh. Wait a minute. I think steps minus one on, yeah, right there.
Would I change this one right here too?
Yeah, yeah, yeah. I think so. I'm not sure. Because if not, I think your solution is gonna work. Oh, oh, go to six. Oh, oh. Check 45.
Hey, hey,
Eh,
hey,
eh,
hey,
eh,
hey,
eh,
hey,
eh,
hey.
eh, eh,
So it was
eh.
-1.
It was minus one. Yeah. Because right there, steps is equal to n, and n is
Is out
it's
of
outside.
range.
Yeah.
Yeah,
So we gotta do minus one, shift it all one by one, and boom.
yeah,
Dude, that's crazy. Memoization coming in clutch.
yeah.
Yes, sir.
Oh, submit it.
Yeah, let's go. Let's see. Ufas. Ufas. Oh, because it's zero. Oh, man.
It's 1.
Yeah. You know what? I think you were right. I think it goes before the if statements, the steps, and all that. Yeah, that goes above the memo.
That's two failed submissions.
It's okay, bro. We're learning. We're learning
You
right
know
here.
what? You're right. Someone told me, and I've known this as well. If you're not failing, you're not trying.
You're not
So you know
learning.
what? So you know what? Let's try to get a 0% submission rate. That means we're
Yo,
trying.
yo, chill. All right, now we can
Dare I
submit
run
it.
it again? Dare I
Yeah, you
submit?
run it. Submit it. Submit it. Hey, beats 100%, bro. 100%.
I
Oh, there's
actually
not
like.
enough. Wait,
I'm
it
like,
says
huh?
sorry. There's not enough accepted submissions to show data. Damn.
Lion. There's 185 people on this question, bro. I. Hmm. Never mind.
Why? What'd you get mad for, brother? What'd you get mad?
Cause like, also, what happened to like? Oh, there it is. Still tells you. Do you want to try it with the dictionary?
We can do it with a dictionary. Yeah. So now here it's gonna be a little different, where we have to check if it exists, right? Like check if the key exists, and if so, grab the value. And then if not, we have to create a key.
Yeah, I think it's still that,
I think it works. Yeah, let's
right?
see. Run it. Yeah, run it. Run it. Ooh, fast.
I haven't seen that in a while.
Here. What does
Oh,
that mean?
okay, okay. Uh, oh. Because there's nothing. There's nothing when error starts.
Oh,
There's no
there's no
keys.
keys. So here we had
So
to add yeah, I think we'll have to initialize it, no? Initialize all the keys.
would we?
I mean, uh let's see, let's think about it. Because if we initialize a key, right, for every recursive function, our recursive call, we say, right, if key doesn't exist, right, we create it. Uh, then we grab the value and we have to check if it's null or anything. And if it's not null, right, we return its value. If not, we calculate the value and then we insert it there. But it's the same. I feel like it's the same thing as just initializing all the keys that we need and then just checking if it's null or not. But I might be wrong.
I think it. I think we just need to have one value in there because if there's
Okay.
nothing, this is gonna be an error. But if there's just one thing, it's gonna say, okay, no, that's not in there, and
Well,
then
I
let's
well in
add
that case
more.
we can add the key n
Which one?
n. We can add n in there since we're not
Okay,
gonna use it.
right here.
I mean, yeah, I think you're the dictionary expert. So
So, how do I do this?
you want me to search it up?
Isn't like what's a that's a string.
Oh, you do memo, then square brackets, the key, and then it will equal the value.
Yeah, it's just I don't know if I just put n, if it will put the value like 45, for example.
No, but you have to do it on another line. I don't think you can do it there.
Oh,
Yeah. So you go, yeah, then you do memo, square brackets, and then the value.
so the value would be.
I would say, yeah, -1. Yeah.
All right, see what this does. All right. So what's wrong with this?
Not
If
sure. Let's see. No, you know what? You're right there. You're getting the value steps -1. You just have to do if steps in memo keys. Yeah, remove the memo square bracket steps -1 and just put steps -1 in memo keys. Because right there you're getting the value. I think so. Yeah, yeah. You do steps minus one. If steps minus one's in memo keys, because right there you're doing memo steps minus one, and steps minus one is not a key, so it's giving you an error because that key doesn't exist. Yeah, I think that's how could work.
You're a
Yeah, there we go.
genius.
Nah, bro, no, no,
You're
no,
a
no, no,
genius.
no, 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 no.
So is that why? Let me see. Let me. I still think we needed this, but let's just double check. All right. Perfect.
Hey, we did it, brother. We did it. We did it. We did it.
Let's see. Let's see. Let me run it again, and then I'll submit again.
Hey, hey,
Come on.
hey,
Come on.
hey.
Nice.
Yes, sir.
I wish I could see our stats, but I guess
We
not.
could do it memory wise.
What are you talking about?
That so we
Oh,
do
yeah.
16 megabytes for the dictionary. What about the other one? 16, 62.
This
That one's the array one. 1662. What about the dictionary? Eh, 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 eh. Array.
you
Array.
know what?
Eh,
Whenever it's
eh,
100,
array. Array.
you know what? That's it. I'm gonna.
Arrays.
It's not gonna let me do this,
It's not
isn't
gonna
it?
let you do it. It's not gonna let you do it.
Hey,
It's not gonna let you
wait.
do it. Arrays. Arrays. Arrays.
Next one.
Hey, we can do it dynamically now. Are you down to do it dynamically?
What are you talking about?
Dynamic. No recursion needed. We just calculate the numbers that we need.
We weren't
Figure
doing
it
it
out.
dynamically right now.
We weren't. That's just memorization.
That's dynamic though.
Part of dynamic, but it's not true dynamic.
So what's true dynamic?
Dynamic means like you don't use any recursion and you just calculate based on the base case. You populate an array, right, with a future what is it called, future cause, right? Like you don't use recursion at all. You just use a loop in an array with no recursion needed.
Why didn't we do that for the easy one?
Because I think dynamically it's a little bit harder to figure out like where we need to do or what we need to do. It's because it's memoization. It's top down, right? Where you just get this big sub problem and you go little, you get smaller and smaller. Dynamically, it's a bottom up where you do start at the bottom and you will go up to the top.
Okay.
But only if you want to. I don't know. It'd be pretty cool to do it because that's what we're learning right now.
Well, that's
With
what I thought we were
dynamic
doing
stuff.
in the first problem.
Well, now it's dynamic.
Oh. Problem.
Huh?
Problem.
Can't hear you. You're too far.
You could read the problem.
Oh, okay. Oh, we're doing this one. Okay, fair. Okay.
Wait, you're saying you wanted to do the other one dynamically?
Yeah.
Oh, okay, then yeah, let's do that.
Yeah. I mean, only if you want to, because I know we said we didn't want to spend so much time in like single problems, right? But I don't know. It'd be pretty cool to do it dynamically. But I don't know how long that's gonna take.
No, let's do it. I thought you were talking about we're gonna do this problem right here that I'm on.
Oh, no.
Dynamically. Like we chose the medium problem to do dynamically and not the
No, no, no,
easy
no.
one.
No, 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 no.
Okay,
I
so
was
you
thinking,
want to switch this one up to try to do dynamic?
if you want to, if you're down for it,
Yes,
I'm
let's
down
do it
for it too.
because that's
All
what I
right.
thought we were doing.
Okay. Yes. Yes. Well, this is memoization. Kind of dynamic, but not quite. Right. Dynamic. What it means is that we are going to um fully remove the recursive part and just do an array with the values that we need. I don't know if that makes
Is
sense.
that always the case in dynamic?
That's a part of dynamic programming. Yes.
Is you use arrays?
It could be whatever data structure, but the point is that you calculate based on the previous values. You calculate the next values,
Okay.
and for this, I'm gonna pull up our class notes so we can guide ourselves with
All right.
some stuff in here. Uh, yada 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 yada. Okay. Mm, Uh. Okay. Yeah, I got it here. So, first of all, right, we're gonna loop through an array, right? Boom. We have two base cases, right?
Okay.
We got either we got three actually. We either got 0, right? 0 position 0 with like an array, right? We have an array of, as I said, 0 index 0 is gonna equal 0. Index 1 is gonna equal to 1. Index 2 is gonna equal to 1. Index 3 is gonna equal to 2, right? Index 4 is gonna go gonna equal 2, 3. Yeah. Let me see. Let's think about it. Let's think about it.
Think about it.
Yeah. Because we have an array, right? We have an array. I'm gonna go to Excalibur for this. Because I have to think about this one.
Yeah,
Let
I'm
me
gonna need
just
that. I'm gonna need that.
yeah.
Can I delete or
Yeah.
it's cold in my room. I'll be right back.
Yeah, it's cold in my room too. I think I
Be
might
back.
put a sweater right now.
Okay.
I did this wrong.
So how is this better than what we did?
So in a recursive function, you're using a lot of space for each recursive call, right? What this is doing is that you are eliminating all that space. You don't need recursion. You don't need to call multiple calls or anything. You don't need a stack frame. You just have an array. And based on the base cases, which are these, you're going to calculate this one, right? So it's pretty much that's all,
What happened
right?
to in class when we've been doing instead of top down, bottom up?
Okay,
Isn't
so
that
top,
recursion?
yes, top down is recursion, right? Because you're doing in a recursive implementation, you have a big problem, and you get its sub problems, right? You disconstruct it into sub problems, right? So you go to top down. bottom up, right, use the lowest problems, the sub problems, to calculate the big problem, right? But I think in a recursive way, bottom up is kind of like impossible or really hard to implement, right? So you guys, we do it in an array, right? Yeah or nay?
Sure.
Fair? Yeah. No,
Keep going.
I don't think you're convinced.
I'm not convinced. No, but I'm waiting
What?
for you to
What?
finish your
Were you not
drawing
convinced? Were you not convinced?
because because
They're both type of dynamic programming. Yes, they're
so
both
for example, we
types.
have n equals 38.
Give me a second. I'm gonna put a sweater on. I'll be back.
Okay.
Yo, yo.
Yo,
Uh huh.
so what I was saying was
Ooh.
n equals 30, for example.
N equals 30. Yeah.
We keep breaking it down, breaking it down, breaking it down.
Yeah.
That's top down.
Yeah.
Bottom up, you're saying you start at the bottom, so that would be like in the zero ones
Yeah.
range, and you
Uh
go
huh.
up.
Yeah.
And the only way
Yes.
to do that is
It's through an array, looping
through
through an
array.
array.
Okay, okay,
Yeah,
bet. I'm good
looping
now.
through
I'm
an
good
array.
now. I'm good now. I'm
Yes,
good now.
yes. Yeah. We're not just gonna get an array, be like, oh, populate. So that we're gonna loop through an array. There's gonna be like a little bit of logic in there to calculate uh the next
So another way of
value.
thinking about it is that top down, you have the base case because
You have
that's
the
where
base.
you're heading
Yeah.
towards. You
Top
don't start at a base case.
down.
You're heading towards the base case. For this,
Yes.
for this one, bottom up, you start at the base
You
case
start at the
and you're
base
going
case. Yeah.
up.
You're going up. Yeah. You're going
Okay,
at the bottom,
okay,
going to the
okay,
top.
okay,
Yeah.
okay, okay,
So that's
okay.
why we use an array or a data structure, because right here,
Because
right?
with recursion, you probably can't start from the bottom.
Exactly, exactly. Because those are your base cases. If you start at the bottom with recursion, you're just gonna hit your base case. You're not really gonna go all the way down, right?
Exactly.
So here, um, in the bottom up, you start with the base cases, right? And our base cases, we said that um, when 0, we return 0. With 1, we return 1, right? So return 2, right? And like we said, right now we're gonna implement our. It's the same logic recursively, right? But now we're just gonna use the 0 and 1, right? We're just gonna start at 2, then 3, then 4, right? For example, at 2, we grab 2, and if you go to the recursive to our implementation, right, we see that. Can you go to the code? Yeah, yeah. You see, right now we start from our solution, our recursive solution, the f on line 22, 23, right? We use those to come up with a new value, right? That's the dynamic, right? When in recursive, we assume those were correct, right? To get the value. So we get the value and assume the solution. Right here, we assert the solution, right, to get the value. So we're working like backwards now because we're going from bottom to top, right? Yay or nay? Because in recursive, right, we get our value and then we break it apart, right? Here on bottom up, we get the solution, right, the least of the least, and we go up. So we're working on reverse pretty
Okay.
much. Yeah. So if we go back, right, we're gonna say, okay, 2 minus 1, right? 2 minus 1 are array. Wait, let me see. Array at position 2 will equal array at position 2 minus 1 plus 2. and we said that this one equals 1, right? So here, this is 1, 2. Yeah,
And can
that's
you
1. That's 1.
explain why these are ones again?
Well, 0 is in our base case, right? If we go back to our
If we
base
hit
case,
0, then
if we hit
we get
0,
a 1.
yeah, if
If
we
we
hit
hit
0, we
less
reach the
than
top.
0, that's a
That's
problem.
0. Yeah,
That's
that's a
0.
problem. So we're gonna have a if statement to check a if this sums, right, or if these subscriptions are negative,
Uh-huh.
right? We just return 0, or we get 0, add it to the other one, and then we have it, right? So we're gonna do an
Okay.
if statement to check that. But we can now assume 1, right? Since we already saw in a recursive implementation that 1, right, is always gonna equal to 1, right? If we have a value 1 equal to 1, we can assume 1 is gonna for sure always equal 1. So we can now just like boom, implement it there, right? Without needing to calculate 1, because we already know for sure, right? That if we hit 1, right, it's gonna return 1, ER and A. Like, because we tracked down the 3, right? We saw that, hey,
If it
when,
hits 1,
for
it will
example, we have 1
return 1, but
here.
there's still a remainder.
Well, that's the thing. If we hit
Oh, no,
1,
it's not.
we do
There's no remainder.
f1 minus 1, f1 minus 2. This is going to return 0. This is going to return 1. 1 plus 1 equals 1. So
Okay.
this whole thing is going to return 1. So now we know for sure 1 is going to be equal to 1.
Yeah.
100% all the time, right? So we can kind of assume 1 is true.
Yes.
Yep. Yep. Okay. So that's pretty much it right now. That's the whole flow we're gonna do. So here, right, we're gonna do first we have to set an array, right? We have to populate an array, right? So we gotta populate an array, right? And then we have to populate an array, and then we have to loop through the array. Okay, wait. So before we loop through the array, we have to set our base cases.
Set the base cases.
Then we have to loop through array. Right? Once we loop through the array, starting after the base case, right? So that's the thing we have to keep on. After base cases, we check if sub is negative. If so, return 0. That's pretty much it. Pretty much it. All of that. But I don't
can't
even.
read this.
Oh my god, brother.
I've been trying to see sub.
Sub is negative.
Okay.
Yeah, and I don't even know. I don't even think we have to even check if we are even gonna hit negative, because if we're starting at position 2, 2 minus 2 is 0, right? And that's the furthest you're gonna go. So we can disregard the negatives too. We just start at 2 for sure,
Yes.
100%. Yeah. So now if we go back to our solution, right? Right. We can comment out everything that recurs. Yeah, right there. And we're gonna create an array, memo, and I think we can do it with all zeros, if I'm not mistaken. Yes, I think we can create it with all zeros. Let me check. Yeah, we can create it with all zeros. Yes. Right, so we do memo times 0 times n, right? Then we say position 0 is going to equal to 1. Position 1 is going to equal to 1. Right? And now we're going to loop through the memo starting at 2 for x in memo for in range of 2. Right there, just start at 2, right there, right? Wait, oh, we have to give it a
Wait,
range, no? Yes, 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 yes. We have to give it a range. So it is length. Length. Or n. Yeah, yeah, yeah. N. Right? So now we're going to do memo x will equal memo x minus 2 or x, yeah, plus x minus 1. Yeah. Then we return n. But here, I think here there's going to be a discrepancy in the values.
return what?
N. N.
Why n?
Oh, no, memo at n. But I think there's going to be a little bit error with the indices because we're starting at
Yeah.
0. So I think it's n minus 1.
Or I mean, we could just do the length.
Yeah, let's do the length. Let me see. Yeah, try running that. Let's see what happens. I think there's going to be a little discrepancy on the values. Try on line
But this needs to
31.
be n minus 1.
No, on line 31, do a +1. On line 31, just do a +1. That way we can get that n, right? Instead of 0 to 2, we're getting 0 to 3, right? So we can get that 3, n at 3. I don't know if that makes sense.
No. Can you explain that
For
again?
example, if you have n, 3n, right? You're getting 0, 1, 2, right? 3 values because you have 3n. But if you do if you do 4 values, you have 0, 1, 2, 3, right? So now you have to include the 3, the index 3 in there. So whenever you do memo n, right, it's not out of bounds because you got the 3 inside the indices. So even though we're gonna still have 4 values, right? Because of the 0. The 0 is the 4th value that we're including, right? So that +1 is just recompensating for that 0.
Okay.
Oh yeah, you got it.
Sure. Yeah.
All right, let's see if it works. I'm excited, my boy. Oh, okay.
Oh.
It's a test case. It's a test case.
Okay.
Oh, you had to do parentheses. Yeah. Yes, sir. Yes, sir. Yes, sir.
I didn't mean to do that.
All good. All good. Isn't that beautiful, bro? Isn't that beautiful? From like a, what is it, 20-line code to like a 5-line code, 8-line code. Wait, whoa. Oh,
Interesting.
where's the where are
Huh?
you getting confused?
No, I just wanted to see what it would
Oh,
be.
okay, I get you. Damn, bro. Submit it and see what happens. Ooh, Fuzz, baby. Smaller. It was even a little bit memory less. less memory than the memoization. You liked it, yeah or nay?
So this is bottom up.
This is bottom up.
I like it.
Yeah,
So
because you're
you're
starting from the
saying right
bottom.
here, you're saying zero
Yeah,
if
the
n
indices.
n
If
equals four. You
right, you're gonna
got
have zero,
zero,
zero, one,
one, two,
two,
three.
3, up to there, right? But you still want to access of number index 4, right? So you do a plus 1. So now n is gonna equal to 5, which includes the 4, right? So you're
But
gonna
why do you
do,
want to access plus four?
because in the problem itself, you're not starting at 0, you're starting at 1, right? Here in our implementation, we're starting at 0. So you're adding that extra value 0 in the beginning, right? Which shifts everything a little one to the right. So you're
What
like,
about this in range right here?
in range you start at 2, right? So you start at index 2 and use the 0 and 1 as your base cases to get 2,
So
right?
that's what I'm saying is why add the plus one?
Because for example on line 42, right? We're returning n, right? Right now, if you access n on line 34, and n is 4, right? If you access n in line 34, it's going to tell you out of bounds because 4 is not in there.
Why don't you
So you
just say
do a,
minus one?
because minus 1, now you're getting the value of 2. You're getting the value of 3. We want the value of 4, right? We're calculating each value. For example, 1 step takes 1 step. 2 steps takes 2 steps. 3 steps takes 3 steps, right? There's 3 ways to do 3 steps, right? So the array is doing it by values, right? It's not being shifted or anything. It's like for 0 steps you take 1 step, for 1 step you take 1 step, for 2 steps there's 2 ways to do it, right? So you want to get the how many ways there are when there you have 4 steps, right? In this implementation, what it's doing is getting the index 0, and it's checking how many steps there are for that index 0. Index 1, how many ways there are for 1. Index 2, how many ways there are for 2. 3, how many ways there are for 2. But right now we're interested in how many ways there are for 4, right? So that's why we have to add the plus 1 to include the 4. So it's 0, 1, 2, 3, 4. So we can have 5 elements. So we can say index 4, how many steps or how many ways there are for index 4? Because we're based on the indices, not on the value itself. Yes or no?
Okay. Yeah, a little bit, yeah.
Yeah, that's what we had to do at the plus 1.
Alright.
Hey, that's bottom up. That's bottom up.
Oh,
Yeah or nay?
that's a yay. I
Yay.
need to go make some food, man.
Yeah, you hungry?
Yeah, I'm really hungry.
All right, brother. We can call it a day here.
Okay.
It was a fun problem though. We
I
kind of
liked it.
extended
I
it.
liked the problem. It was
We
pretty nice.
extended it, but we covered some fundamentals, like really good fundamentals.
Yeah.
You know, like we actually applied what we learned in this problem.
Yes.
Yeah, yeah. But hey, brother, if you're down to call it here, I'm down to call it here too.
Yeah. I need to
Alrighty.
go make
Hey,
some
sure.
food.
Hey, no
You do
worries,
the
no worries.
outro, man.
Alrighty, let me just do. Carlos is hungry, hungry, big boy, hungry. I got you, brother. I got you. I got you. All right, boys. All right, guys. Thank you for tuning in. It was a good stream. We kind of extended this easy problem for an hour and 20 or something, but for us, we could like really, really practice some fundamentals and learn what dynamic programming is, memoization, and a bottom up and top down solutions are. So it was a really good problem. I enjoyed it. Right. I think Carlos also enjoyed it. So, and I know Carlos has to make some food. So if you guys have any comments, right? Leave them out in the comment section. Leave a like, subscribe, and if you got anything to say, Carlos?
Nope. I'm
No?
hungry.
Alrighty. Alrighty. So thank you guys for tuning in. Have a great day, great night, great evening, great morning, whatever the time zone is. In your places, have a great day and thank you guys. See you guys next week. Bye bye.
Bye.